As we've discussed in earlier lessons, previous architectures in the data center were actually designed for more client-server or north and south traffic. In this case, because it was designed for that north and south, east and west traffic was actually inefficient and unpredictable. It was also designed around spanning tree, which in some cases can be very complex, and had poor scalability because it was very hard to insert resources. For instance, if I wanted a set of servers to use a firewall, depending upon where I inserted it, some of the servers could use that firewall and other services couldn't. And if I did somehow get the traffic for all of my servers to the firewall, usually what I was doing was hairpinning that traffic through my network, which was very inefficient and in some cases very complex, as well as it slowed down my traffic or added more bandwidth to my network than what I actually needed. So over time, as our applications have evolved, we have started to have more east to west traffic inside the data center than we have north to south. And that actually lends itself towards a different data center architecture that we call a spine leaf fabric. A spine leaf fabric was designed to be very deterministic as far as bandwidth and very deterministic as far as latency. It's also built with faster speeds in mind, so it's usually 10 or 25 gig down towards the servers and 40 to 100 gig between the spines and the leafs. In this type of an architecture, we actually create a partial mesh in the infrastructure. It's almost a full mesh, but not quite, because the leaves only connect to spines and spines only connect to leaves. And everything enters and exits the fabric through our leaves. Nothing but a leaf actually connects to a spine. So if I was going to connect my traditional network or my core to this network, I would actually connect through the leaf the same way I would plug in a server or a firewall or another layer 4 through 7 device. The benefit of this architecture is I can actually do a lot of my local routing and switching at the leaves. And if I want to get to a service or device on any other leaf, I can do so in 2 hops or less. This network is also designed to be very scalable. So if I want to add more capacity, I simply add more leaves and plug them in. If I want to add more bandwidth or availability, I simply add more spines. This makes it so that any port on my leaf in any location across my data center that's part of the spine leaf fabric can basically be a high-speed server, a high-speed firewall, or a high-speed load balancer, and any device can have fair access to that device anywhere on the network in 2 hops or less. This is an example of the Nexus 9000 series platform, where I'm using a 9500 series platform for the spine, and I'm actually using a 9300 series platform for the leaves. I could do this in 2 different modes. I could do this in what we would call an NXOS mode, which is a traditional mode that we're used to seeing in our Nexus 7000, 5000, and 2000 architecture. We run a traditional version of our software on there. And then there's also what we would call our SDN version or our ACI version of the software that can run on these switches as well, but requires some different licensing and has other benefits that we'll discuss in other lessons. Please join me for the next lesson, 4.5, Examining Data Center Media Types.